chapter 4. This, like I said, is where we start finally getting into the meat and potatoes. Some of this is a rehash. We start out talking about declaring variables, data types, that kind of stuff. Start talking about some of the mathematic operators, some of the logical operators, I believe, and some of that kind of stuff. This is where it all begins with the programming, coding part of it, I would say. You can't do anything without variables for the most part, and you start from the very bottom, the variables, the data types, and we'll work our way up into eventually for loops and all that kind of stuff like that. So taking a look at the slides, the objectives part 1, given an arithmetic expression and the values for variables and expression, evaluate the expression. Use numeric and string data as needed within your applications. This means you should be able to do any of the following. Declare and initialize variables and constants. We've been doing that already with these console applications we've done. Code arithmetic expressions and assignment statements. We've been doing a lot of that already. Use the static methods of the math class. I know as I've been walking around labs, I've seen a few of you using like round and stuff like that for math. We'll take a look at some of those today. I think it's round, min, max, square root, and a couple other ones. The only ones you really use a lot would be random, which generates a random number, and you can see that's the next bullet on the list here. And the min and max to try and find min and max values and get min and max values. So don't worry about the square root, and some of the other ones we'll cover over. The random and the min and max are probably the ones we'll use the most. Oops, this mouse rolls quick. Cast and convert data from one type to another. Use correct scope for your variables. Scope is just where you declare your variables so they can be used. You can use either them in, I believe it's called block scope, and then a global scope. Declare and use enumerations. Work with nullable value types and a null coalescing operator. Distinguish between a variable and a constant and give the naming conventions for each. Describe any of these data types in int, double, decimal, bool, and string. We've covered quite a few of those in the first week or so that we've been doing this stuff. Describe any of these terms: a literal value, a null value, empty string, concatenate, append, escape sequence, string literal, verbatim, string literal, and nullable data type. That's just how you get some of your values coming back from users and how you can set them up for data checking and stuff like that. Describe the order of precedence for arithmetic expressions, and we briefly talked about that last week, I believe it was. Just the orders you have to do everything in for the math to work right. That's why on that one division problem that we had where we did the averages, you had to put the addition in the parentheses first. That way it did all that before it divided it. If not, it would have divided the number and then added it up, and you would have got the wrong values for it. And then distinguish between value type and a reference type. Describe the difference in the ways that casting the two-string methods of a data structure, the parse and try-parse methods of a data structure, and the methods of the convert class can be used to convert data from one form to another. And then describe the differences between class scope and method scope. And that's just kind of what I was telling about. Kind of like a global variable compared to a local variable. If you've done any coding, you kind of know what that means. A global variable, you can use it anywhere in your code. Method scope means it has to be within that method for it to pick it up and actually use it. So the built-in value types of C#, and you guys have already looked over this stuff from that data type worksheet that you did in the first part. I wouldn't get too wrapped up on this. Most people just stick with the very basic stuff, like your ints here is what they'll use for most numbers. Every now and then you'll use a byte if it's something very, very small, like one letter or something like that. A lot of times there'll be a char is what they'll use if it's a letter, a byte if it's a small number. But byte, S byte, assigned integer from value of -128 to 127, short, 2 bytes, int 16 integer from negative 32,768 to positive 32,767. So as we saw those convert to ints that we were doing earlier, and some of them would say int 16, int 32, int 64. That's what they're talking about here. They're converting it from a text string, and this int 16 would be creating it to a short. So when you saw those pop up, that's what it was telling you. Int 32, that's what we used a lot because it was just converting it to a regular int. And like I said, that's the most common number data type you usually use coding this stuff out. There's a uint, unsigned integer. I'm not going to spend too much time on this. I'll cover it real quick just because you may use long occasionally if it's like a big number, and you can see here it's what, 9 trillion or more. I'm not a math guy, so I couldn't tell you the exact, like more than trillion, but that's how it is. Int 64, a long, so if you have a super long number, that's what you'd use your long for. See, the int only holds up to 2 billion, I guess that is. So that's when you'd use the long instead of the int. The float is a non-integer number with approximately 7 significant digits. So if you have smaller money values or whatever, you could use float for that. A double, man, this mouse. A double is a non-integer number with approximately 14 significant digits. So you can see double is a little bit bigger than a float. It takes 8 bytes compared to 4, so it eats up a little bit more space in your memory and your storage. And that's what the bytes are for, to show you how many blocks of memory it uses up to store these values in that. And then finally we get to decimal. Decimal is a non-integer number with up to 28 significant digits. Occasionally use decimal. A lot of times it's double. Double is big enough usually to hold most numbers. And so a lot of people stick with double. If you know it's going to be a smaller number, you can use a float. And then if you think it's going to be a large number you can use a decimal. I think occasionally in labs we'll use a decimal for something here and there. Char can hold up to 1 single Unicode character, so if you just need one letter like an A or a B, something like that, excuse me, you can call it a char. And then of course Boolean is, bool is always true or false. You can use a 1 or a 0 for it. You can say true or false, however you want to do it, yes or no. But bool, the only thing that checks is see if it holds a value for true or false in it. How to declare and initialize a variable in 2 statements. We've gone over this many a times. As you can see, the type here is the data type, and then you give it your variable name. You can see they're using camel casing here, where the first letter is lowercase, and then the second word in your variable name begins with a capital letter. That's called camel casing. I think later on in these slides they talk about Pascal casing, and that's for constant numbers. If we come across it, we'll take a look at it. If not, I'll give you an example of what I'm talking about here in a bit. So you can see on the example here, they declare the data type as an int, and they give the variable name called counter. Then the next line down, they initialize it and then give it a value, counter equals 1. So a variable stores a value that can change as the program executes. Like I said, it's just a space to hold a value in. Usually it's what the user's passing back. We can set it like the counter example above. If we use a counter, we can always set the counter value. You can set them at a value of 0 right away if you want to. If you know that you want your value to start out at 0, you can declare it and set it to 0. Naming conventions: start the names of variables with a lowercase letter and capitalize the first letter of each word after the first word. This is called camel notation, or as I said, camel casing. They call it camel casing also. That's how you want to set up your variables. If you know it has 2 words, first word is lowercase, beginning of the second word is uppercase. Try using meaningful names that are easy to remember. Like I said, that one guy used superfragilistic expialidocious. For starters, that name sucks just because it's so long and it has nothing to do with the code itself. Usually you want to try and have your variable mean something that you're coding, so you or anybody else that looks at your code can go back and tell what you're trying to get done. How to declare and initialize a variable in one statement. We've looked at this a couple times last week, and they have a lot of examples down here. Type is always the data type, so if you see examples like this and it says type, that's what they're talking about, is the data type. And then of course the variable name. So, and then they initialize it by giving it the value. And when you initialize it, you always use the equal sign there, so you can see they're doing, here's an integer, type is int, variable name is counter, and then they initialize it and give it the value of 1. Long number of bytes. You can see the camel casing in here with the lowercase n, the capital O, and the capital B. 20,000 float interest rate 8.125. And when you use a float, you have to use that F at the end there. And I believe when we get down a little bit further, it'll explain why you have to put the F on here for the float. Decimal, you got a double here, a decimal total. And then when you use a decimal, you have to put an M at the end to show that it's a decimal. And we'll, like I said, we'll talk a little bit more about this hopefully later on. I know in the book it does describe it in the book, so if you actually read chapter 4, you'll understand what's going on with it already at this point. Int is the next example. They call it population 1, 173432. Int population 2. If you read the book in C# 7, version 7, with larger numbers you can put underscores on it and it'll still understand what number you're trying to say. So I'm guessing it's going to be like a comma. So 1 comma 734, instead of the comma you put the underscore, and that way you can read your number a little bit better and it will pick it up still properly as a number. So if you start working with some larger numbers, you can keep that underscore in mind. I think we're using version 7.0 or greater. I'll have to double check. Double, star count. When you get into some of these larger math numbers, you can put the pluses and stuff in there, lowercase letters. I know we don't do any of this in our labs or homework, so don't get too hung up on that. And I've actually never ever seen it out in the real working world, so don't get too worried about it unless you get a job coding for some kind of math company or something like that, or if you're writing software for doing math code. Other than that, you won't see much of this. Char letter, of course, I mentioned it's just one letter, and since it's a character and its character is a string, you've had to put quotes around it to show that it is part of a string. Bool value, or saying bool, naming it valid, and it's true or false most of the time. You'll see some other variations in there. You can put Y or N or T or F, but the bool you'll use quite a bit because as you do some validation, you'll check to see if it's valid, and you'll use a variable a lot of times called like is valid, and then you can put true or false in there to show that it is valid or not. And as you go through your validation stuff, you'll flip that is valid from true to false to show that it is working, or false to true and stuff like that. So, and then here they do a variable data type is int. They give it the name of x, and then declare it and initialize it with the value of 0, and same with the y. And they're doing it all in the same line, just kind of like what I showed in some of those examples with that console application, is declaring and initializing all your variables on one line instead of having to do it out on multiple lines. How to declare and initialize a constant syntax. Here you started out with the keyword constant, C-O-N-S-T, and that miles to kilometer one that we did, we used a constant in there. The type, and I think we used int or double for the type in that. And again, that's the data type. That's the data type that we use, is this type here. And then of course the constant name. Here they're using what they call Pascal notation, P-A-S-C-A-L. Pascal notation. So Pascal notation, the difference is the first letter in the first word is capitalized, and in every follow-on word, the first letter is capitalized. So if this was just a regular variable, it would be a lowercase c and an uppercase N. Being a constant, it's capital C, capital N. Or as our example that we did in the lab, you can make all of it uppercase and then put a underscore between the two words to show the splitting of the words. Either way is fine. I'm guessing the book talking about it in here, you may want to go more with the camel case or the Pascal notation, Pascal casing, but that's up to you. I'm not going to take off for it. I don't think many of your works will get mad if you do it that way, but they may have another naming convention way to do it, so that's up to them. So an example, you got the constant, you declare it's a constant. Our data type is the integer, and then days in November is our variable name, and we initialize it and assign it the value of 30. Another one, constant, they use decimal as the data type. Values or variable name is sales tax, and then they initialize it and give it a variable or a value of 0.075. And again, that M at the back there shows that they're using the decimal data type. So there. Description, a constant stores a value that can't be changed, so whatever you set it at, that's what it stays at throughout the code. You shouldn't change it at all. It shouldn't be changed. Capitalize the first letter of each word of a constant name. This is known as Pascal notation. Try to use meaningful names that are easy to remember, and you should do that all the time when you're declaring your variables or even naming like text boxes or anything else. Labels, try and name them something that's meaningful to your code so it's easy for you and anybody else that looks at your code to understand. Now we get into the arithmetic operators. You will be using these quite a bit as you code, so I would try and get familiar with these. We use quite a bit of them, or I showed a demo at one time or another on them. Just the plus operator. Addition adds two operands, and the operands are just the numbers on the left side of the operator and the right side of the operator. Subtraction subtracts the right operand from the left operand. Multiplication multiplies the right operand and the left operand. Division divides the right operand into the left operand. If both operands are integers, then the result is an integer. So you can see multiplication, they use the little star for your multiplication sign. The division is a slash. Here's that modulus that we talked about last week. And it's just the little percent sign, and what it does is returns the value that is left over after dividing the right operand into the left operand. So that's when we did the eggs one, we checked for 12 and that dozen, and whatever it was left over was our single eggs and stuff like that. So that's the, let me get back. Like I said, this mouse scrolls like super fast. So that's the main 5 operands that we have here, are the arithmetic operators, is the addition, subtraction, multiplication, division, and modulus. Some of the other ones are positive sign, a negative sign. The positive sign returns the value of the operand. Negative sign changes a positive value to a negative and vice versa. Increment adds 1 to the operand. So if you have x, it just adds x plus 1. So if your, x is 6 and you do the increments, your x would end up being 7 after you increment it. And then the decrement works the same way. If your x is 5 and you take 1 away, you use the decrement, it drops it down to 4. You will use these quite a bit as you're doing loops and counting and stuff like that, because you're going to keep wanting to add 1 to your count and stuff. The book, I forgot what page number it is. I should go get my book. Give me 1 second. I'll run and get my book, and I can point out some page numbers and stuff to you. Hang on. So if you look on chapter, if you look at chapter 4, page 99, that's where they talk about the arithmetic operators. They give you some examples down there. Let's see if this next screen gives us some examples. There we go. Pretty much same thing that's in the book. So your int x equals 14. We're declaring a variable named x, giving it the data type of int, and 14 is the value they assign it. Then we do an int y, give it the value 8. So when they do these arithmetic ones, that's what they're using, is this 14 and 8 when you see the x and y. So here they're just doing a simple addition. They're doing x plus y. So 14 is the x, 8 is the y, and then our result, there goes the mouse again, is 22. X minus y, so 14 minus 8 is 6. X times y, 14 times 8 is 112. And then x divided by y is 1. X modulus y, so if you look, we see how many times 8 will go into 14. 8 goes into 14 once, with the remainder of 6. So that's why our result here for that modulus is 6, because all it's doing is looking for a remainder. It doesn't care about the math or anything else. All it's trying to do is pick up that remainder. Then you got negative y, which is negative 8 plus 14. You know how to add with negative numbers. That gives you a value of 6. And then the increment and decrement. The increment y is, or the value, answer is 7, because y starts at 8. Am I looking at that right? Yeah, and it decrements it down 1, so it goes from 8 to 7. X, they're incrementing it. X starts at 14, so x goes up 1, so x is going to be 15. And like I said, you'll use the incrementing more than the decrementing, but they're both good to get familiar with, because as you do counts and stuff like that, you will be using that quite a bit. Here's some using decimals. Decimal is the data type. A is the variable name that we're giving it, and we're assigning it the value of 8.5. And again, that M means decimal. And then the second one is decimal, data type, variable name B, and that equals 3.4. And again, the M shows that we're using a decimal. I'm not going to do the math because, like I said, I'm not a math person, but I know 8.5 plus 3.4 does equal 11.9. I can see that off the top of my head. A minus B would be, what, 5.1? Hey, I didn't even look at the answer. But so as it goes down, you can see it's doing the same thing. The decrementing, 8.5, it goes down 1, so it goes to 7.5. Incrementing B, so it's at 3.4, that'll go up 1, so and then it goes up to 4.4. On the result 16 here, the third line up from the bottom, you can see it has negative A. A is 8.5, but when we put the negative A, then it makes it that negative 8.5. So, like I said, you do use math quite a bit when you're programming one way or another, but you don't have to do a lot of addition and subtraction problems. It's like real world stuff. You may have to figure out adding money together or something like that, or a bunch of pieces are ordered. You know, you have to calculate the number of pieces ordered and stuff like that. So you do use math. It's just not crazy. You don't use the modulus a whole lot of times and stuff like that. You don't switch a lot of numbers from negative to positive or vice versa, but you do use incrementing and decrementing quite a bit. So that's the ones I would try and get most familiar with. Doesn't hurt to get it all, but. And then assignment operators, again, we're assigning values to our variables when we see that equal sign. So like here, we're assigning the value of 8.5 to A and 3.4 to B. So that's when you assign the values to them. When you hear me say that, that's what I'm talking about. Addition, it just takes the total of the last one and adds on the new number to it. Subtraction does the same thing. Multiplication and division and a modulus. So as you go through these assignment operators, we'll end up using them. You can add strings together with some of it. You can add values together. And I think in our labs and homework we'll end up doing some of that. If you look at page 100 in your book, it kind of gives you a brief example of how to do it. It shows like month equals month plus 1. And then they do a month plus equals 1. And that just adds 1 onto the month instead of having to type it out. And then the even easier way is just do month plus plus. And again, that's incrementing the month and making it go up by 1. So that's another way of doing this addition operator. Excuse me. I think should have some examples here. Yeah, so we're going to give us some examples here. Syntax for a simple assignment statement is just as you do everything else. You come up with a variable name, and the variable name should have already been declared. So then you just use the variable name and then the expression that you want, which is like month plus 1 or whatever. And this will show you some here. This here is just assigning a statement, and we've been doing this since the beginning. We create our variable and assign it a value. New counter, we assign it the value of whatever counter is. Discount amount, we assign it the value of what the subtotal times 0.2m is. And then the total, we assign it whatever the value of subtotal minus discount amount is. We've been working with this in the console apps from the beginning, so this shouldn't be anything too new. It might look a little bit different now that we're actually talking about it and describing it a little bit more in detail. But that's all we're doing is we're declaring a variable. We already gave it a data type previously from this example here, and now we're just assigning it a value. And when I say assigning a value, that's usually what I mean is taking our variable and then giving it some kind of value to it. So statements that use the same variable on both sides of the equal sign. So again, they're just doing total, and then they take whatever this value of total was and add 100. And the M shows that it's a decimal. Total, take the total value that we declared earlier and has a value probably earlier and do minus 100 with the decimal again. Price equals price times 0.8. And we've done some of that for, I know on our hands-on test we had one or two like that. I think adding those prices of the t-shirts and stuff up, we had to do something like that to get the sales tax and the taxes and that. So statements that use the shortcut assignment operators, total plus equals 100m. So you can see up here, all they're doing is taking a total variable and just putting that value of 100m with it right off the bat. So then you don't have to worry about, you can type out what, 3 things instead of 4 or 5. Total minus equals 100. The shortcut assignment operators, if you feel comfortable using them, I would say use them. As you get better in your coding and understand this a little bit better, you'll more than likely start coding it out with the shortcut assignment operators. Sometimes to me, the long version of it looks better, reads a little bit better. And so until you get comfortable using the shortcut operators, I would just stick with these the regular statements, not the shortcut as much. But that's on you. I know the better you get coding, the more you'll end up using these shortcuts in almost everything. So the order of precedence for arithmetic operators, and that's what I was talking about earlier. The increment and decrement go first. After that, the positive and negative numbers go next, and then you'll start doing the multiplication, division, and modulus, and then addition and subtraction. Calculation that uses default order of precedence. So you can see they got decimal is the data type, discount percent is a variable name, and they assign it the value of 2.2 for the M is the decimal. That's showing a 20% discount. That's stupid mouse. Decimal price. So the decimal is the data type, price is a variable name, and that equals 100. And again, the M is a decimal, so they're showing it as a $100 price. Price equals price times 1 minus the discount percent. So the price would be 99.8. So what they would do here is do the price times 1 and then subtract the discount price off of it. Calculation that uses parentheses to specify the order of precedence. So down here at the bottom you can see what they're doing now is you do the parenthesis first, which you take 1 from the discount price and then times it by the price, and that gives you 80. So you can see just by putting the parentheses around the example from the bottom to the top one how much it changes the price just by using that parenthesis to get the order of operations done first. So again, the 1 minus the discount price gets done first because it's inside the parenthesis. This one here, the price gets multiplied by 1 first because the order of operands, and multiply it before we subtract. And you can see there ends up being a price difference by using the order of operations in the parentheses to get that done. The use of prefix and postfix increments and decrement operators. So here they declare an int, give it the variable name of A, and assign it the value of 5. Same with this one, they declare an int with the variable name of B and assign it the value of 5. So int Y, they're incrementing the A first, so the A goes from a 5 to a 6. On this one here, they increment second, so they have the B before the plus sign, so that means you get the value first and then increment it. If it has a plus and then A, that means increment the number right off the bat right away, so that's why it goes from a 5 to a 6. And this one here, B starts out at a 5, and then you increment it, and that B ends up, or the Z ends up being a 5. So they take the number first and then do the incrementation. That's odd looking the way they have it here. But B starts out at 6, and then it goes to the 5. And the book gives a little bit better explanation of how they do that. When you see an increment or decrement operator as a prefix to a variable, the variable is incremented or decremented, and then the result is assigned. But when you use an increment or decrement operator as a postfix to a variable, the result is assigned, and then the variable is incremented or decremented. I'm wondering if that should have been a minus to show that it was a 6 and then drop down to a 5. But anyhow, you may use that. I know you'll use the incrementing and decrementing quite a bit when you code. And so you'll want to try and get a little bit familiar with these because, like I said, when you do loops and everything, you're going to increment your loops to count through them and all that kind of stuff. So how implicit casting works, casting from less precise to more precise data types. So you go from a byte to a short to an int to a long to a decimal. And that's just taking a small one and going to a larger data type in order to be more precise with your data types. That's why some of them, when you see the double or that, it'll have 7 or 8 decimals behind it. That's how precise it's getting. It's getting to so many decimal spots past the number. So an integer, it just is a whole number. There's no decimal point in it, so you could have 32. But then you switch it to that double, and that double could be 32.00735 to get it that precise of a data type. Same with the short, the float, and the double. Float's not as precise as the double as we saw back on these data types. What slide number am I on? 20. That we saw at the data types at the beginning here. You can see the byte's only to 255, but we go to a double, and you can hold a non-integer number with 14 significant digits. The float only uses 7, the double uses 14, so you know the double's a larger, more precise number than the float can turn out being. So something to keep in mind as you're dealing with these data types and doing the cast. A char is not nearly as great as an integer. An integer can hold all the billions, a character can only hold 1. So double grade 93, convert int to a double. So you're taking that int 93, converting it to a double. Taking the character A, converting it to an int. You don't see that done too often, mostly because you keep your integer as a string and not, or a character as a string, not necessarily as an integer. Here they're declaring a double as a variable name A, assigned to value of 95, but of course using a double, they're using a decimal spot behind it. And then they have integer B, assigned to value of 86, and then C, which is another integer, and assign it the value of 91. So then they're doing a double and an average, A, B, C, and then they're converting B and C to a double values. So they're converting B and C to a double to work with the decimal. And this is implicit casting. C# can convert some of this stuff over for you. Some things you may have to convert. It just depends. Sometimes you'll get that little red squiggly error to tell you that you implicitly, or you have to actually convert it yourself. Page 104 in the book talks about using casting. Some of the description: if you use code and an assignment statement that assigns a value with less precise data type to a variable with a more precise data type, C# automatically converts the less precise data type to the more precise data type, and that's why it can implicit cast it, or sometimes we have to convert it because it's taking a more precise data type and converting it to a less precise data type. And so you want to read up a little bit more about casting. It's on 104 and 105 in the book. How to code an explicit cast, the syntax for coding an explicit cast. Take the data type and the expression. So here you take int and grade, and it converts a double, that 9.73 or 93.75 into a double, so it gets rid of the decimal point and just picks up that grade of 93. Char letter, character 65, converts the int to a character, and the letter is A. And that probably has to do with your key code. There's a thing called a key code. Each key on your keyboard has a value, and later on, I know we do at least one lab that we need the key codes to learn to figure out what key the user's typing in and such. Here they do double 95, an integer B 86, C 91. So they're converting these to an integer instead of a decimal or a double, so that gets rid of the decimal place and it gives us just that value of 90 instead of having a decimal with it. And then a decimal result, they do a decimal B divided by decimal C, and the result has decimal places. So that's another way to implicit casting for that. So like I said, look over page 105 and 104 and 105, and that'll give you a fairly good explanation of it. Use that quite a bit in coding throughout, but I wouldn't get too worried about it right now. Most of the times we do everything, we declare it and just keep it as the same value types as we go through. How to code an explicit cast, that's what we just went over. 5 static methods of the math class. So we'll use that using system that we always see at the top of our code. That system allows us to use these math classes. The math classes, like I said, you don't use them a whole lot in the real world. You'll use the math round, you'll use a lot just because you're rounding numbers, getting it to a precise number. The math power you don't use much at all, and that's like doing square roots and stuff like that, or getting the power of a number for exponents and such. And then the syntax of the square root method is just getting the square root of a number. And then the syntax of the min and max method, that gets the minimum of a number and the maximum of a number. So if you put a range of numbers in, it'll give you the min and max. So to code those out, the math being the class, since it's a class, it starts with a capital letter. starting with the capital M for math. So anytime you use math, you'll start it with a capital M. And then the method for math is dot round. So math is an object again for the class. And that dot round means use this method. And again, we know it's a method because it has this parentheses here behind the round. And then again, the power, capital M for math, since it's a class and an object that we're using. And then pow for the power. And then it's a method because, again, it has a parentheses behind it. And you can see it says method afterwards too, just to reinforce it. Syntax of the square root, again, capital M for math, dot, because we're using the object and the method from it as square root. And then you put the number in, and it'll give you the square root of the number you're using or put in there. And then the syntax of the min and max, math, it's min, max, they're doing both of them here. And you can put the number in that you want. Man, for the min and max. I'll get it there someday. So that's min and max. Here's some examples of it. So they declare an an integer named ship weight. They assign it the math.round, and they're doing a ship weight double, and that rounds to a whole number. If it happened to have a decimal in it, it'd get rid of the decimal and round it up or down depending on the number. Double, total order, math.round, total order, and then 2, it rounds to 2 decimal places. So if it's something like 32.3571, it would stay at 36 because it would round that second decimal place up. Double area, they're doing an integer, or a double, data type double. The variable name is area. They're assigning it the value of the math dot power, radius 2, and he times it by math.pi. That gives you the area of a circle. Like I said, real world, you don't use power much. You won't use square root much, so I'm not going to go into too much explaining what all this is doing. They're taking an integer type called double. The variable name is square root x. They're assigning it the value of the math.square root method. And that x is just the value you put in there, and it, like I said, it'd give you the square root. So 16 in there, the square root would be 4, I believe. Like I said, I'm not a math major. The integer type here is a double. They give it the variable name of max sales, and they assign it the value of math.max. They take last year's sales, this year's sales, and that will give you the max value out of those two. And then same with the minimum. Next is the data type is integer. The variable name is min quantity. They assign it the value of the math.min, and they take last year's quantity and this year's quantity, and that'll give you the minimum of the two numbers. Results from static methods of the math class. Here's a statement. Math round 23.75. They're rounding it to 1 because that 5 makes it greater than the 4 or whatever the rounding true terminology is. It rounds it up to an 8. Same with this one. Math round 23.85. They're rounding it up 1 place because that 5 and it's 1, it stays an 8. I don't know why technically that would be, because usually when it's a 5 it rounds up 1. So I don't know about that. Usually when it's a 5 it rounds up 1, so that should, I would think, be 23.9. And then the next example, math.round 23.744. They're doing it 2 places. 2 is the 4 is at the end there, so that would keep it at 7.4. I don't even touch my roller and the thing jumps like crazy. So math round, 23.75 goes to midpoint rounding away from 0. So 23.75, and that's what I would expect here because that 5 is that midpoint rounding. And maybe because they did this midpoint rounding that away from 0 is why it actually did round up that way. But that's what I would expect it to do anyhow. The math power, 5 and 2 is 25, so they're taking 5 times 5, the power of it, 25. Square root 20.25 is 4.5. Math max 23.75 and 20.25. The max is 23.75, and that's why he gets it there. And then you have a math min 23.75 and 20.25, and of course 20.25 is the minimum of those two numbers, so that's why it picks that one out. So instant methods of randoms class. Let's take a break here. We'll take about a 15-minute break. Be back about 9:30, and I will pick up on this, and we'll keep going through some of the math stuff and a few more things with strings and numbers coming up. So go ahead, take about a 15-minute break, and we'll come back, and we'll keep working on this stuff. Any questions, comments, or anything so far? If you do, you can either say them over the microphone or hit me up on Discord, and I'll try and answer them for you. So now we move on to the instance methods of the random class. The random class you can use quite a bit in the real world. I know we will a few times in labs. We do a rock, paper, scissors game that you use random in, and I think the Pokemon game that we'll do in labs uses random a couple times in that. So yeah, anything that you want random, this is what you would use for it. The method you use is this next method, and you can see it's a method again because it has a parentheses behind it. That means you can pass parameters in there if you need to. And you can see down here we do pass parameters eventually into it, a max value that we're looking for, and then a min value and a max value, depending on what you're doing. Description, the next returns a random integer value that is greater than or equal to 0 and less than the maximum value for the int type. Next, with the max value parameter in there, returns a random int value that is greater than or equal to 0 and less than the specified maximum value. The next method with the min value parameter and a max value parameter returns a random int value that is greater or equal to the specified minimum value and less than the specified maximum value. Then the next double method returns a double value that is greater than or equal to 0.0 and less than 1.0. So that's getting pretty small, pretty specific in between those two numbers there. I don't think I've seen the next double one used very much, if at all. Most of the time it's just the next methods that get used. In the next slide, this is how you would do it. So random is part of that math class, and then random itself is an object. So what we do is we say we're going to make this random. We're going to use the object random, give it a variable name. This variable name they give it is number. Then they create what they call a new instantiation of the random method. So this means we're going to use this random method with our number now. And so that's kind of how it's set up. Is random is the object that we're using, number is the variable of the new object we want to create, and this new random creates that new object using a random method for us for number. So as you can see below, the statements that use the methods of the random class, we use number dot, and again that's because we use this random class, the object from it, and assigned it to our number value. So now we're using number dot next, and that's just going to return an integer greater than or equal to 0 and less than to the max value of the integer 32 data type. And like I said, we kind of looked at those at the beginning of the class. You don't have to get too caught up on them. Here they're doing number.next. They're passing the one parameter in, and you can see the max value with the one parameter here. The value is 101, so they're going to give us an integer that is greater than or equal to 0 and less than 101. So you can kind of set the limits on what your random number shows up to be. Here they're doing the number.next. The min number is 1, the max number is 101, so you'll get an integer that is greater than or equal to 1 and less than 101. And then they're doing that number.next double. You get a double that comes back that is greater than or equal to 0.0 and less than 1.0. Side note, every time I see that 0.0, I think of the movie Animal House when they're reading off their grades, and he's like, your grade point average is a 0.0. So I chuckle every time I see that. All right, back to the real deal. Code that simulates the roll of 2 dice. Here they're using the object random, assigning it to the variable, or declaring the variable number, going to be using a random object. Here they create the new random object, instantiate it. They're using this the integer variable data type, and then assigning it to the variable die, which then assigns the number.next 1 through 7. So that means when you roll a dice or a die, the number that's going to come up is going to be greater than or equal to 1 and less than 7. And that way you know you're getting the values of the dice, or die, I guess, technically. And then they would do a second one for die 2, use that number.next 1 through 7. And so that's an example of rolling 2 dice and getting the value back from each die. I don't think we do any kind of dice games in our labs or that, but I do know we use the random a number of times in it. So now we're moving on from the numbers into the strings. Initializing, how to declare and initialize a string. A string is just anything that's text. And to show that it's text, you always put it in the quotation marks, and that way you see that it's some kind of text and you know right away that it is text. I think if you look on page 110, 111, a couple more through there is where they start talking about strings in there. How to declare and initialize a string. Our data type now is going to be a string data type. Before we're using data types for numbers. Now we're going to use what's called a string data type. Assign it a variable name like we've been doing, and a variable is just a storage area to hold some data or values in it. In this case, we're going to assign it, and the value and data that it's going to hold is this text called invalid data entry. Now you can see it holds periods or anything like that. Anything inside the quotes is what's going to be in the string. We've been using a lot of strings with that string string interpolation that we've been doing through the console apps. So string message 2, when you have just 2 empty quotation marks like that, that means it's a blank string. There's nothing held inside of it. When you print it out to the screen, it will be blank because you're not putting any data in between those quotation marks. And another way you can do it is string message 3, and they assign it the value of null. You will come across that quite a bit as you code. Sometimes it comes back as a blank if you set it as a blank, and if you don't set a string as a blank, a lot of times it comes back as a null. Just means there's no data in there, there's nothing there, and a lot of times you'll have to code to error handles. This will throw errors at times depending on how you code it. So you may have to do like what they call null checks to see if there's a null value there or not. And if it affects your program, you need to fix it to where it will give you a blank string or do something else besides throw this null, because the null, like I said, can cause an error depending on how you're coding out your code. Sometimes it's looking for a value or something and it's not there, and that null shows up. And since the null is not a string, it's not a number, it can cause some errors. So how to join strings. So they're creating the data type is called a string here again. The variable name is first name. It's camel cased because the lowercase first letter uppercase second letter, or second word I should say. They assign it the value of Bob, so you can see first name comes out as Bob. Then they have a string, last name equals Smith, so last name shows up as Smith. And then now they're going to join them together, which is called concatenation. So if you ever hear concatenation, it's just adding strings and variables to a line and printing them out together. So you can see here they're doing a data type string. The variable name is name. And now they're taking the first name, which we created 2 lines above, which is Bob. And they're using the variable name here, so there's no quotations or anything around it. The plus sign. And now in here they have 2 quotes, and that's an empty space, so they're just putting a space in between the first name and last name. And then they use another plus to join the last name on with the rest of this. So when you print it out, you'll see name is Bob Smith. We get the Bob from that first name up there. We get Smith from the last name. And the plus is there. Join it together. And in between where they join it together, you get the quotation, empty quotation marks, the space. They put a space in there to space it out. If you just put 2 quotes with no space, it'd be wedged together a little bit more. So that's just a nice way to do it. We've been using string interpolation for the most part instead of this concatenation. This concatenation can get to be a problem when you have a lot of variables and a lot of text that you have to put all these plus signs in. You have to put spaces properly around some of the text to make it look good. So I would stick with string interpolation if possible. If for some reason you can't use it, concatenation is fine. It just can be a little bit more confusing. How to join a string and a number. So here they create a variable type or data type of double. The variable name is price. They assign it the value of $14.95. Again, they're using a double because we have a decimal spot in there. Can't use an integer if we have a decimal. And then we declare a string, data type, give it a variable name of price string. And then they do assign it a value, price, and the price colon $sign is all in quotes, so that's part of the string. And then they add the price onto the end. So they concatenate it again with this plus sign. It shows that they're concatenating it, and they're using the variables value of this price that we created to put that $14.95 in there. So then when the string comes out, it comes out as price colon $sign $14.95. And you can see the 14 is right up against that $sign because they didn't put a space after the $sign. That would have put a little space in there. Or they could have put an extra space, a plus, an extra space, and then the price, and it would have spaced it out. It wouldn't look right because they're trying to make it look like a dollar. But as an example up here, how they got the space in between Bob Smith, and the reason there's no space in between the $sign and the $14.95. How to append one string to another string. It's pretty much the same thing. We just kind of did all that. They do declare a string, a data type of string, give it a variable name, first name, assign it the value of Bob. And again, we know it's a string because it has the quotes around it. String, last name, give it a value of Smith. And then they do string name. So then they're assigned the value of first name plus. And doing that, the name here that they declared, this variable, is going to be holding the value of the first name, which is Bob up here. And then they're concatenating a space on it. So name is now going to hold first name plus a space behind it. Here they take name and they reassign it. So then they take the name, which has the first name of Bob with the space behind it, and then they add last name onto it. So then when you print name out, in the end you'll get Bob Smith as the name. Pretty straightforward. You'll see that quite a bit in your coding career as you start coding. Is they're just taking the variable name, putting first name plus the space, and then taking the name again and adding the last name to it. So like I said, you'll see this quite a bit. And I kind of talked a little bit about it at the beginning of using the plus, and they're doing numbers, I believe, in the earlier slides that we looked at. But it works the same way. How to append one string to another with the shortcut plus equal operator. So you see they have string, again, first name Bob, string, last name Smith. Then they do create a variable with a data type string, give it a name of name, and equals first name plus. Well, instead of doing the name equals name plus last name, they just do name, and they're adding that last name onto it with that shortcut plus equal operator. And that's just a shorthand way of doing it. A lot of people will use this just to save a little bit of time rather than having to type out that last little bit up on this last line up here. And you see it's just a shortcut for up here. So it's just taking name, which is the first name in the space, and then adding that equal last name to it. So what they're doing is concatenating it by using that plus sign and then assigning it the value of last name. So it just runs out to Bob Smith. So it might be a little bit confusing. That's kind of odd to see it like that. But once you start coding for a while, that'll become second nature, and that's how you'll end up doing it a lot of times. Common escape sequences. So as you're writing these strings out, I think it gives us an example in the next slide. As you're typing your string out and it gets to be a long string and it's starting to run off your screen and you don't want it to run off your screen, use the /n and it'll drop it down to a new line as it prints out to the screen. The /t makes a tab in your string. /r is a return. 2 slashes is a backslash, and a backslash with a quote is putting a quotation in there. String interpolation is nice because, like the backslash and the quotation, most of that it picks up. You don't have to worry about all these escape sequences. But if you're just doing strings and concatenation with strings in that, you'll need to know what these escape sequences are. Like I said, slash is new line, slash is tab, /r is return, /backslash, and /quotation. There's an example here. So they declare a data type string, give it a variable named code, and assign it the value of JSPS. They create a variable with data type decimal, give it a name price, and it's 49.50. Because that M is on the end of it, we know that it's a decimal. I don't know if it's towards the end of the chapter or more towards the beginning. But they do a fairly good job in the book explaining the M being a string literal or a literal data type, and the F is a literal data type. So I think it's towards the front when they talk about doubles and floats, or decimals and floats. But to get back to it, then they create a data type string, give it a variable name result, assign it the value of the string part is where the code and the colon is inside the quotation marks. Doing a concatenation. They put the plus code and then another plus to continue on with our string. Well, you can see here they put it in a new line, and then they do price $$. That's a string because we see it inside the quotes here. And then they concatenate the price into it, so they put the plus, price, plus, and then they're showing that they want a new line to start again inside the string quotes here. So when it prints out to the screen, it'll look just like it does over here. Code JSPS will be on one line. Price $49.50 will be on the second line. So here they do string names equal Joe. And then they use, they have it tab Smith, tab Kate, tab. So they declare a string, give it a variable name, names, and then equals Joe. And then down here they do a Joe And this, you can see it's a string because it's all in quotation marks. They do a Joe, and then they tab it to Smith. And you can see here is Joe, and they tab over to the Smith on this line here. Then they do a Kate, a return with Kate, so a return will bring it down to the next line. So you can see Kate drops down to the next line. And then they do a tab for Lewis, so you can see Lewis tabs over from Kate. And then they have another return, which puts a blank line underneath it. It's kind of confusing the way they have it written out in this slide example, but what they're doing is the string names is down here, is what goes with the variable name. This is what they're assigning it, is this line here. So they're saying take the name Joe, then tab it to Smith. So they go Joe, tab it to Smith, and then we're going to take the return for Kate. The return drops it to a new line, so then the Kate goes down to the next line. And then from Kate, they're tabbing over to this Lewis. So then you see the space in here from the tab. And then the Lewis, they do a return after that. So then that's why there's this blank line underneath here. It's because of that return. It's just kind of odd the way they do it. So now they're doing a string here, declaring a variable type of string, giving the variable name path, and assigning it the value of C, colon. And they're using the double slash to get a slash in here. C#.net, double slash again to show another slash for files. And you can see when it prints out to the screen, it's C:/C#.net/files. But because we're using a special character in a string, we have to use that double slash to get the regular single slash to show up. And in a string message, since they're putting quotation marks around this X, they declare a variable data type of string, give it the variable name a message, assign it the value of type /X/quote to exit, and then when it prints out, it prints the quote marks around the X. But to get that, you have to put the /quote around the X. That's kind of why string interpolation is nice. You don't have to worry as much about that stuff. They have a thing called regex, and I don't know if we actually use it in C# or not. But regex is a way to use like the /n/t, these double slashes, the slash quotation mark. They have a list of them if you go look it up. And let me go grab it here real quick. I'll see if I can find it. Regex cheat sheet. Let's see what this looks like. So you can see here, regex, we did some of this in JavaScript. It checks for like a digit here, another digit. This is looking for a word character, white spaces, looks for numbers, looks for special characters, or puts special characters. So you can see here's that tab that we just talked about, the return, the new line feed. This is line separators. So there's quite a bit of them. When you start doing validation, heavy into validation, you'll start using this regex a lot. And it can get to be a pain because there's so many different combinations you can put in your code that it gets easily confusing because you're using /A looks for a capital letter, /Z looks for a lowercase letter at the end, looks for a capital letter at the end. Somewhere that it just shows up in the code. So there's a lot of different combinations of these regexes you can put in there, and it gets to be a hassle. And you can see quite a few of them. You can concatenate these, or I wouldn't even say concatenate them. You just put them all together, and it does validation checks, but it can get very confusing very easily. Back up so it looks good. So that's how you use some of these escape sequences here. The more common ones that you'll use: the new line, the return, the tab, double slash for the single slash, and then the slash quotation mark to get quotation marks around what you're trying to do. Examples that use verbatim string literals. So string names. String is the data type. Names is the variable name that they give it. They assign it the @ symbol, Joe Smith. And you see Joe Smith. And then they have Kate Lewis. And Kate Lewis. So they use the @ symbol to get it to do some of the stuff that they were doing in the last one. I don't like this way as much. I'd rather use the just a regular string with the escape sequences or string interpolation. You can see string path, they use the @ symbol and then put it all inside a string here with the quotation marks, and it prints out, oh man, this mouse prints out just like it was on the left hand side. You don't have to put the double quotes and or the double slashes. And same with this one, it uses the @ symbol type, and then you put a couple extra parentheses around the X to get it to show up with the print or the quotation marks. I'm sorry, not parentheses, quotation marks to get it to show up around there. You don't see this type used as much in coding. You may occasionally run across it, but not very often. You'll see the escape sequence characters more often, or like using string interpolation. And here's .NET structures for defined value types. We kind of looked over these. I think these are showing that's whether it's signed or unsigned, and that was part of that data type value thing that you had to do for the first lab in the class last week that was due. Same thing, some common .NET classes that define reference types. I just moved my mouse and it jumps. This is getting very annoying. So string, the keyword is string. That's the string class we're using. There's a lot of things in a string class that you can use, different methods to get stuff done. The object keyword, reference any type of object. And we've done some of that with that random. That was an object we used. And a couple of the other ones that we've used so far. Common methods for data conversion. To string. If we have a number that comes back, gets returned, and we want to return it to a string or use it as a string, we use this toString method. It's a method that converts the value to its equivalent string representation using the specified format. If the format is omitted, the value isn't formatted. So you have to tell it what type you want to convert it to or from. And then we have the parse. Parse a string. Static method that converts the specified string to an equivalent data value. If the string can't be converted, an exception occurs. So there's like parseInt, parse double, a couple of those that you can parse your string into. And then we have a try parse. I think I gave an example of this way back when. You take a string, you tell it what you want to parse it into and what you want it to come out to the screen as. So a static method that converts a specified string to an equivalent data value and stores it into the result variable. Returns a true value if the string is converted, otherwise returns a false value. So I think we did one where I took a string, trying to think of what I called it, and then converted it into an int, and at int you give it a new variable name and then start using that variable name after that. We've done like the 2 decimal, we've converted the decimal data types. 2 double, we've done some of that. We've definitely done the 2 int 32. We haven't done the 2 char, 2 bool, or 2 string yet, but they work all the same as what we've been doing. We'll continue to use these a lot throughout these Windows Forms applications, just because the data type you're getting in most of the time is through a text box, so it's a text and you have to convert it to whatever you need to convert it to. When I give you some examples and do some demos of that, I'll kind of show you some of that eventually. Statements that use toString parse and try parse. Excuse me. Create a data type decimal, give it a variable name of sales, assign it the value of 25.74.98, and again that M goes at the end because we're using a decimal. Excuse me. Data type string, give it a value or a variable name of sales string, assign it the value of sales.toString. So what we're going to end up doing is taking the sales and making it a string eventually. And then we take sales, give it a decimal.parse sales string. That's taking a string and making it a decimal. So this one here takes the sales string, takes sales to string, makes that decimal string. This one decimal.parse, it takes the sales string, converts it to a decimal. Decimal.try-parse, and this is what I was talking about earlier. It takes the string, which is sales string, and then when it comes out, if it's good and can parse it to a decimal, it comes out as the variable name sales. And then we use this variable name sales for the rest of our code to actually use that decimal value that we just parsed into a decimal. An implicit call of the toString method. And again, they take a double data type, variable name price, assign it the value of 49.50. And we create a string, a data type string, give it the variable name of price string. And then we do price, and then that's the price with the colon and the dollar sign. That's part of our string, and then we concatenate and add price to the end of it. So that automatically calls the toString call since it's part of our string there. That's an implicit call of it. You have a try-parse method that handles invalid data. So we have a string, data type, give it a variable name of sales string, assign it the string value because it is in quotation marks. So even though it looks like a number, because it's in these quotation marks, it's still a string. And then we're doing a decimal, creating a data type decimal, variable name sales, giving it the value of 0. And again, it's using the decimal because that M behind it with the literal data type. And then we do a decimal.try-parse sales string. We want to come out at sales, and that sales is set at 0, so it comes out as 0. And because the sales string, they're checking to see if it's a string, and they want to parse it to a decimal, and it can't be parsed to a decimal. That out sales, it still ends up being a 0, so that's why it comes out as this 0. You probably hear the baby in the background there. And conversion statements that use convert class. And we've done some of these already in those console applications we've done. Is we create a data type called decimal. The variable name is subtotal, and then we assign it the value of convert that decimal subtotal text. And this is how it's going to look when we start doing these Windows forms. This is getting the value off a text box from a Windows form and converting it to a decimal. Same thing with this N32. It takes the value from a text box that we create in a Windows form and converts it to an int. And again, subtotal text, convert to a string, subtotal, that's converting a decimal to a string. And again, we're going to convert this int32 decimal to an int. So like I said, with these Windows Forms applications, because everything's pretty much coming in through a text box or whatnot, we will be converting almost everything. So get familiar with that. You should be somewhat familiar with it already because of the Windows console apps that we've been doing, or those console apps we've been doing. The only difference is now, instead of passing that read line through to convert, we're going to be passing the values from those text boxes through to convert. So standard numeric formatting codes. C is for currency, P is percent, N is number, F is float, D is digits, E is exponential, and G is for general. I know we'll use C, P, N, F quite a bit. I don't think we use D, E, or G very much. But like I said, when you start getting into some of that regex stuff, you'll end up seeing these D's used for decimals, or yeah, for digits. I'm sorry. How to use this toString method to format a number. So you do a string, declare the data type of string, give it the variable name, monthly amount, assign it the amount dot toString, and they're putting a C at the end of it, so we know that wants to be a currency. C is for currency, so it takes that value and makes it 1,547.20. Another string called interest rate, interest to string, and the P is 1, so we want 1% each place behind our number. Again, P is percent. String, quantify string, quantity to string, N is 0. So they just leave it as it is, put the zeros behind it. Here they're doing a float to 3 spots. And they're saying the float, the decimal spot, because it's a float, and they want 3 spots behind it. So 818 is the 3 spots behind it. If it's at F1, if it's at F1, it would just be 432.8. F2 would be 81, and then the F3 we get 8. If we had F4, it'd be 81, and then whatever number we had after that, 8181. So it's just kind of how to lay those out. I think that's on page 118, 119 in your book. Syntax of the format specification used by the format method. Index format code. So then you just use your variable and then whatever format code you want. And so that's why they have 0 with the C, 0, 0, 0 like that. How to use the format method of a string class to format a number. So you just take the index and then the format code you want. Index, format code. Code that declares and uses variables with class scope. So as you saw when we were creating those console apps, we had that initialize, or no, actually it was when I showed you the example of the Windows forms last week or week before. When we create one, we have this initialize component here. Well, up in this class, you can put variables up in that class, and that will use them as what they call a global variable, so it can be used throughout your code, and that value can change wherever throughout your code. And then you have them in here where you do it, and inside of here they call them method variables because they're only used with inside this method, and our method is this button calculate click, so they would only be used inside of there. When we put them up in this class up here, you can use them globally, and they can be used anywhere inside your code. So how to work with scope. The scope of a variable determines what code has access to it. If it's a global scope, that means all your code has access to it. If it's a method scope, only that method that you're using them in has access to it. So the scope of a variable determines what the code has access to it. If you try to refer to a variable outside of its scope, it will cause a build error because it can't find that variable, so it causes a build error. The scope of a variable is determined by where you declare it. If you declare the variable within a method, it has method scope, just like I said earlier. If you declare a variable within a class, but not within a method, it has class scope. So that's why if you declare it up top in the class, up in the top part of the class, the whole class can use that variable now. If you code it just inside the method here, only inside the method can use the values of it. It's outside, it's up in the class is actually where this is, so then this whole thing can use the variables here that we declare. You'll use that a lot in in C Sharp, even Java, you use that a lot. You'll declare global variables. I call them global variables. They call them class variables in here. Most of the time they're called global variables, or you hear somebody say global variables. That's what they're talking about, is a class variable that can be used anywhere in your code, and the values for it change. And then you have what they call method variable. A lot of times you'll hear them called a local variable. That means they can only be used locally, which is in that method that you're declaring them. So if you hear me say global, that's what I mean. If you hear me say local, that's what I mean. And when you talk to more coders, more than likely you'll hear them say that. Is that not true, Matt? Do your friends not say global and local more? Hopefully Matt's still here. Oh, well, you say you have some friends that do a lot of coding and whatnot that work in the business, and I don't know how much in depth you get to talking with them about it, but no. So I didn't know if you'd hear them ever say like, "Hey, I use these local variables or these global variables," compared to calling them class variables or method variables or method scope. All right, but yeah, if you hear me say it or you hear somebody say it, that's kind of what they're talking about. So if it has class scope, it's just a class variable that it can be used anywhere. If it's method scope, it's a local variable and just gets used locally in that method. So if you hear me say it, that's what I'm talking about. If you hear somebody else say it, that's kind of what they're talking about. A variable with a method scope can only be referenced by the statements within the method. A variable with class scope can be referred to by all the methods in the class. The lifetime of a variable is the period of time that it's available for use. A variable with a method scope is only available while that method is executing. A variable with class scope, again, which is a global scope or a global variable, is available while the class is instantiated. So as long as it's being used, that global or class scope variable is available. If it's a method, it's only used while that method's being called and run. Some of the constants in the form body style enumeration. Constant form body style. Fixed dialog is a fixed text border typically used for dialog boxes. Form border style dot fixed single is a single border that isn't resizable, and a form border style dot sizable is a resizable border. This talks about some of the styles that you can use when you start doing these window forms and stuff like that. I don't know why they threw it in here. Syntax for declaring an enumeration. You do an enum and an enum enumeration name and the type is the data type. So you have a constant name 1 and then the value. You don't see enums used a whole lot. I know on one of the last projects I was on, they were trying to use enums a lot just to store variables and hold them. And it shouldn't be a variable that changes. It should be pretty much a constant. And you can see up here, they name it as a constant. They just don't declare it as a constant because of this enum. And I don't know. Let me see what they have in the book for it. Yeah. An enumeration, which is an enum, defines a set of related constants. Each constant is known as a member of the enumeration. So it's just a way of holding a group of constants that you'll be using. By default, enumerations use the int type and sets the first constant to 0 and the second to 1 and so on. So if you want to reference them, you can reference them by the number. So like 0 would be the first value up here that you would reference. 1 would be the second number. To use one or more other integer data types, you can code a colon after your enumeration, followed by the data type. And that's what they're doing here. So if you want to use certain data types for them, you could do the constant name and then the value and then the type. And to specify other values for the constants, you can code an equal sign after the constant name followed by the integer value. That's kind of what they're doing right here. So like I said, you don't use enums a lot. I can't remember if we use them at all in our labs or not. But here they show you an enumeration that sets the constant values of 0, 1, and 2. And by the constant values of 0, 1, 2, they mean this is 0, this is 1, this is 2. So if you call this enum terms and the value 0, you would get net 30 days is what would return. If you called the enum terms and got the value 1, you get this next 60 days. And the enumeration terms 2, you'd get this net 90 days. So here they're assigning values to them, and the value is a short, and they're assigning a 30, 60, 90. So then when you call it now, you'd get a value of 30, 60, or 90 instead of the 30 days, 60 days, 90 days. Statement that uses these enumerations, terms T, because that enumeration here, they said call it terms. They're referencing it here with that terms object, giving it the value of T, and then they're pulling that terms.net 30 days. That 30 days would give you the 0. That 60 days is 60. And the string S terms net 30 days to string. That string, they convert it to that net 30 days. Like I said, I don't think we use enumeration much, if at all. You see it used a little bit out in the real world, not a whole lot. Like I said, one of the last projects I was on, they kept trying to use enums and we're having all kinds of issues accessing it properly and stuff like that. I think a lot of stuff now is going to JSON instead. So just something to keep. Another one of those bullets in your holster or whatever you want to call it. Just another thing that you should know in case it does come up or you see it. But I don't think we use much of it here in class that I'm aware of. I can't think of any from the labs and stuff I've done. But it's not too bad once you get used to it. It's just a group of constants that you're using instead of one constant value that we've used so far. It's just a group of constants, then you can call that group and pick out which one you want out of the group. So here's how to declare a value type that can contain null values. So quantity is null, quantity is 0, quantity is 20. That int quantity sets it to null, I believe. Double check so I'm not telling you the wrong thing. Yeah, you use that question mark to declare a nullable type. So it's saying int, you're declaring a variable named quantity. This mouse about ready to break this thing. So we're declaring a variable with the data type of int and giving it the name of quantity. Well, with this question mark here, that's saying that this value quantity can be null if it needs to be null or if it comes back null. So if it does come back null, it's not going to throw an error. So that's kind of a safe way to code for in case a value comes back as null. A lot of times you still want to do a null data check to double check on it. But by doing this int with the question mark, that's saying quantity can come back as null, so don't throw an error. It's all right to do it that way. So here they're doing a decimal, saying that the decimal can come back as a null. So this variable sales total, if it comes back with the value of null, it's safe, it won't cause an error, and even they're assigning it the value null here. So they're saying that this sales total value can hold the value, the sales total variable can hold the value null and not throw an error. Here they're doing terms, and again that terms is coming from our enum set that they created up here, seeing it's the capital T. saying if this payment term comes back null, that's okay. We're not worried about it. I can do it that way. We can set it to the value of null. That's okay. There's not going to be an error. And then here they're doing, it's commented out. So it's a little note saying a string message is null. It's not necessarily allowed by default. So string message null. Two properties for working with nullable values types, has value and value. And this is kind of a null check here is what I was talking about. So they're saying this has value property. It returns a true value if the nullable type contains a value. Nullable type contains a value. Returns a false value if the nullable type is null. So that's doing a null check to see if it has a null in it or not. If it does not have a null, if it does have a value, it returns true. If it does not have a value and returns null, then it's false. Then they do a value check, returns the value of the nullable type. How to use the properties of a nullable value type. And here's an if statement, if quantity, and here's our quantity up here. Quantity here. If quantity has value, drop down here and then get the value from that quantity. So it's doing an integer, declaring a variable quantity and saying if this quantity has value, go get that value from quantity and put it in this quantity variable we just created. So that's kind of how null check works. Like I said, when you code these, depending on how in-depth you get, you will want to do some of these null checks just to make sure it's not going to break your code at times. Like I said, sometimes if there's a null there and expecting a number or a string or something and that null value is in there, it will throw an error. As you're doing the code, I guarantee you'll get some of these null errors come up. You'll end up debugging, and as you debug through, you'll see your value is null, and that's part of the reason why it's breaking, because you're expecting a value, but a null's coming back. So let's kind of keep this in mind. Like I said, a null check is what it is, a null value check. How to use the no coalescing operator to assign a default value. So you do an int quantity equals quantity, and it does the double question marks. So what that does, it checks and it returns the value of the left operand, which is the left side here, which is quantity. And if it isn't null in the right, and it checks to see if the right operand is. So it's doing another, like a shorthand null check. I don't like these as much. They're a little bit confusing as you're reading through the code. I actually like to do the actual null check this way. Just looks a little more clean. You're welcome to do it either way. This is more of a shorthand way of doing it. How to use no coalescing assignment operator. And then like I just said, that the no coalescing operating assignment operator assigns the value of the right operand only if the left operand is null. So it's checking to see if the left operand is null, and then it assigns it a value to the right. And honestly, I haven't seen much of this out in the real world. Most of the time you go fix your error so it assigns the value properly, so you don't have to worry about nulls when you're doing your null checks. How to use nullable value types and arithmetic expressions. So they're saying here that they're creating a data type of decimal, a variable name of sales1, and assign it the value of 3267.58. And again, the M's there for the decimal. Well, the question mark is here, and again, that question mark means that that value can be nullable. So here they're using it. Here they're using it, and they're saying sales 2, because it has that question mark, sales 2 can be nullable, so they assign it the value of null. Then they do this check here, decimal sales total is 1 plus 2 sales. So if either one of these come back null, it's okay, it works, it's good. And of course we see that number 2 here is null. And because that null is in there, it's going to make the whole result come back null, because you can't add a number to a null. And so you'll get a null value on there. And that's when you do some of this coding that you come across and whatnot that you do. That's one way you can see a null show up. Sometimes it will skip a number, or something happens to where the value is null. And you just got to go back through your code, debug it, and look and see why that value is null instead of not what you're expecting. And so some of the methods that we get to use, like that to text and some of that stuff, could cause something to come back null. So there's a chance that that might happen. So as you're going through these, that's why you might see a null come through it. So if you get it, don't freak out. Debug it, go find out why that value is coming null. It might take you a little bit of time to understand why the value is coming back null, but you got to go debug it, fix it. That's just all part of being a coder. So here they do an invoice total form. This is if you're following along in the book from the beginning. They go through, create a nice little program. If you want to learn more about this and get more into it, I would recommend, as you read your chapters, work these problems through or do their examples. They make some nice little programs and stuff like that. I think Mr. G and his full stack development class, that is one thing you do, is just follow the book front to back and make that app completely and stuff like that. So keep that in mind if you're looking for something extra to do. They make some interesting examples up and do them. So the controls that are referred to in the code, I don't think I'm going to go too much into this because it's going over what I guarantee you by the next time I do a remote class, I will have a different mouse. But they're going through what's up in here. You got your label, text, button, and a button. Here's the text, button. That's just showing what it's doing in this screen up here. We're going to take another break here in a few minutes, and after the break, I'll give you some examples of some basic Windows forms that we'll be working on. Here's the event handler for that form, so when you click the button, it does all the math stuff it's supposed to do for you to get your total and stuff. And then they have the exit button. Click that and it closes. So that's just kind of what they're doing. Like I said, if you follow through the book and do their examples, you'll make a nice little application. Hell, you do it, put it on your portfolio, show it as your own, kind of change a few things up, make it look good, make it your own, put it on your portfolio. Here's a little bit more of an enhanced version of it. So that's what that is there. They show some class variables that they're using, so they declare these up top in the class. These can be used throughout your code. These are local method scope variables in here, so that's why they're inside the button click event, since that's technically a method. And there's the body that starts the body of our method. There's that squiggly that ends the body of our method there. Here's another start of a method. And so this mouse has got me unhappy, so I'm going to skip over the rest of that. We'll kind of wrap up this and we'll take a break here as soon as I finish this part up, and I'll come back and give you some code examples. So the objectives we learned today, or what we're going to apply, is given an arithmetic expression and the values of the variables in the expression, evaluate the expression. Use numeric and string data as needed within your applications. This means you should be able to do any of the following now. Declare and initialize a variable in constants. Code arithmetic expressions and assignment statements. Use the static method of math class. Generate a random number. Cast and convert data from one type to another. Use the correct scope for your variables. Declare and use enumerations. Work with nullable value types. and the null coalescing operator. Distinguish between a variable and a constant and give the naming conventions for each. Describe any of these data types: an int, double, decimal, bool, and a string. Describe any of these terms: literal value, and that literal value is that M and the F for the float and the decimal. Null value, empty string, concatenate, append, escape sequence, which is the /n/t's. String literal, verbatim, string literal, and a nullable data type. And that verbatim string literal was with the @ symbol in the front of it. Describe the order of precedence for arithmetic expressions. Distinguish between implicit casting and explicit casting, and distinguish between a value type and a reference type. A value type actually holds the value in it. A reference type goes out in memory and pulls it back from memory. Describe the differences in the ways that casting the toString method of a data structure, the parse and triparse methods of data structure, and the methods of convert class can be used to convert data from one form to another, and describe differences between class scope and method scope. So that's Chapter 4. I would highly recommend reading it. There is a lot of valuable data to pick up in this. Like I said, this starts the meat and potatoes of coding. Read it, reread it, get familiar with it. Do these labs, practice with these labs with it. This is the beginning building blocks for coding. So try and get familiar with it as much as possible. I think what I will do is I will do code demos tomorrow in class. I'd rather do it in class. That way if you guys have questions or whatever, you can just ask me in class instead of having to mess with the microphones and this and that. So I will do code demos in class tomorrow. Today, go ahead and work labs. I will be here all day till 3:30, and if you have questions, you can message me on Discord. You can voice chat with me on Discord of them. You can do what you want, how to get hold of me. But I will have Discord up all day. I will be listening to it. End of day, I will check attendance again to make sure everybody's here. So in a little over an hour, I will double check Discord, take attendance one more time, make sure everybody stayed on and is working. So Chapter 4 labs are open. Chapter 4 hands-on written test is open. Let me look at the syllabus real quick and see when that hands-on test is due. Not hands-on test, written test. I don't know why I keep saying that. Oh, and I mentioned earlier, I don't think that my microphone was working. I did start grading the first hands-on test. I don't know why, but I read the grading scale wrong. And so some people's grades are off. I'm going to go back, go through that, fix the grades. If you got 100, you're good. You don't have to worry about anything being fixed or changed. People that didn't get 100, I need to double check your grade, and then I will push it back out there in the rubric and let you know that it's been updated. Let's see, when's this hands-on or the written test due for Chapter 4? Yeah. Due at day 9. Read Chapter 4 and complete written test due at day 9, which is actually Tuesday. So yeah, Tuesday. So beginning class tomorrow, so make sure you get that knocked out today. I would start on that first. Take probably a little bit longer than these labs, probably, since I did the chicken example for you. But when you start these labs, you may have to glance back to Chapter 3 to kind of get familiar with working with these Windows Forms apps. And then tomorrow, I will do probably at least an hour of code alongs and code examples of these Windows Forms and some basic ones, just to make it easier asking questions and stuff rather than doing it over Discord and whatnot. So Anybody got any questions, comments, concerns at this point? I'm not hearing anything, so I will turn you loose on labs. They should all be opened up. Like I said, I have Discord up. I will be